this is a nuclear reaction. And the next target that you need to be able to do is to be able to balance nuclear reactions, which are actually kind of easy because you just need to make sure that the mass numbers are the same on both sides. So let's look at it. 4 plus 27 is 31. 30 plus 1 is 31. 2 plus 13 is 15 plus 0 is 15. Okay, there are 4 different particles that you will deal with. 4 different types of radioactive particles. You may want to write this down. And by may, I mean you definitely want to write it down. Alpha particles, symbolized by a little fish, is 4,2 helium. Is it a helium nuclei? No, but in essence it's the same thing as a helium nuclei. Helium nuclei have 2 protons and 2 neutrons. Alpha is 2 protons and 2 neutrons. Beta, symbolized by a B with a little curly thing here, is 0, -1 electron. A positron, which is a positive beta, is going to have the funny B with a plus on it, and it's 0, +1 E. And then finally, a neutron is an italics N, and it's 1, 0, N. So you're going to need those. You're going to need those symbols when we are doing these kinds of questions. Okay? All right. So here we go. There may have been some mistakes in your notes, so please keep that in mind. I think I messed something up, a few things up, but I have changed them in the PowerPoint. So just keep an eye on this. All right, so here we go. Polonium-212-84 becomes an alpha particle plus what? Asher. 212 equals 4 plus what? You need 2 things in chemistry. You need your calculator and you need your periodic table. So if both are not out, then you are not ready for chemistry. Go, Asher. What plus 4 is 212? What plus 4 is 212? 208. Does 208 help you identify what this thing is? The answer is not really. Correct, because there could be any number of isotopes that have a mass number of 208. Okay, so you cannot tell what this is quite yet. Here we go, Asher. What plus 2 is 84? Not usually. 82. Now, does Mr. 82 tell us who he is? 82 is the atomic number, the number of protons, and that is the same for every different element. So it is lead. So the bottom number, my friends, is always going to tell you what it is, not the top number. All right, how about this one? 143. 61. Yep, the arrow's on the wrong place there. So fix it. The arrow's in the wrong place there. Okay. Yes. Okay. So, Ben. 142 plus what is 143?
1.
60 plus what is 61?
1.
Man, he's good. And who is number 1?
Hydrogen.
Very nice. All right. Hunter. 253 plus 4 is what? 253 plus 4. 257. 1 plus what is 257? Does that help you identify what this thing is? Nope. Doesn't help you at all. 99 plus 2 is what? 0 plus what is 101? Does that help you identify what this thing is? What is it? (101) Mendelevium. Mendelevium. Jackson! 238 plus 1 is? Not usually. You might want to use your calculator. 238 plus 1 is 239. 92 plus 0 is? Okay. Now, this one's kind of special in that you have any number of 1, 0 neutrons that you need to account for. Sometimes reactions will actually release more than one tiny little particle. So what I suggest you do is add up 110 and 126, and that'll tell you how many of these little 1, 0 neutrons you need. So 110 plus 126 is 236. 236 plus what is 239? Okay, so you're going to need 3 neutrons. 3 neutrons in order to balance everything out. And since neutrons don't give you anything, so 36 plus 56, does it equal 92?
No. Yes.
Use a calculator if you're having trouble with this simple addition. All right. Is this one a mistake? No. Yes. The 17 should be 19. Okay. Emily, 37 equals 37 plus what?
Wait, on ours it's CL. Let me just change it.
Yeah, change it. This is CL. No, it's K. I'm sorry.
What?
It is K.
Okay.
Number 19 is K. That was right.
So change it to CL. Change it to K.
Okay. Ready? 37 equals 37 plus what?
0.
Very good. And 18 equals 19 plus what?
1.
That gives you 20.
4.
19 plus 1 is 20.
Oh, negative.
Negative 1. And who is 0, negative 1? Look on the chart that I asked you to make. That hopefully is not on your periodic table. You need to do it on your notes.
Beta.
Oh, that one. Oh, beta. No. I made it on the side of my paper.
Actually, I'm looking for little e.
What? Well, yeah.
That is a beta particle. All right. So, finally, thorium-232 undergoes radioactive decay. So, we're going to follow Serenity from the moment that she's Serenity all the way till she becomes Bob. Okay. Tom. She becomes Tom. So, we're going to follow her entire journey. She will either decay by giving off an alpha or a beta, and along the journey, we're going to discover something very interesting. Okay, so since this is Serenity, all right, the first thing she will undergo is alpha decay. What will she become? Serenity, what plus 4 equals 232? In other words, 228. What plus 2 is 90? All right, so look up on the periodic table who number 88 is. So the first element you become is radium. Okay, now you need to remember 228, 88 radium because we need it right here. 228 88 radium. So that's who she has become now, and at some point she will emit an alpha particle, a beta particle. And what is the symbol for beta particle? Let's see, Isaac, you do this one. What's beta? Well, yes, but I'm talking about the nuclear symbol. It's 0 on top, and on the bottom, -1, and that is basically an electron. Okay, here we go. So who does Serenity become after she becomes radium? 228 equals 0 plus what? Isaac. 0 plus what is 228? 228. And that, of course, does not help us one little bit. -1 plus what is 88? And who is number 89? What? Actinium? Actinium. So after she becomes radium, she becomes actinium. And actinium will undergo decay. Beta decay. Let's see. Cal and C. What is the symbol for beta decay? All right, here we go. 228 equals 0 plus what? 89 equals -1 plus 90. So what's really cool is at this point, Serenity comes back. Hi, Serenity! Long time no see. It's been 56 years, but she is back. So is it possible for an element to go back to its original identity? Yes, it is. Yes, it is. Okay, but she's not happy being Serenity. She never was. She wants to become somebody new, so she undergoes alpha decay. Riker. What is alpha? Look on the little chart that I told you to.
Here's the helium.
Well, give me the numbers.
4, 2.
Because helium is really not going to help you. All right, so 4 plus what is 228?
224.
If you understand what's going on, you're free to go on to the end. 2 plus what is 90?
88.
And 88, once again, is radium. Radium! Radioactive, radioactive. Oh. All right, alpha decay. Spencer.
4, 2, 13.
What plus 4 is 224? What plus 2 is 88? Who is number 86? Radon! 220, 86. Radon. Alpha decay again. Gracie. What is alpha decay? Four plus what is 220? 2 plus what is 86? Who is number 84? What? I can't hear you, I'm sorry. Polonium? Polonium. 216, 84, polonium. Bailey. Another alpha decay. 4 plus what is 216? 2 plus what is 84? Who is number 82? Excelente. Oh, forgot to memorize it. 212, 82, lead. Let's see. Jeffrey.
What?
Beta decay.
Let's see. 0, -1.
All right, so
212, 81,
And who is 83? Matamoros. Killer of rice and beans.
Yeah.
Beta decay.
0, -1.
Top number.
212.
Bottom number.
I'm still on
What minus 1 is 83?
84.
And who is 84?
Polonium.
Back to polonium again. 212, 84, polonium. Alpha decay. Emmy. What plus 4 is 212? Oh, what? What plus 2 is 84? Who is number 82? Finally, Veronica, who was hoping I would forget her. 208, 82 by beta decay. Zero plus what is 208? -1 plus what is 82? And finally, after all this time, serenity becomes bismuth. As in Nunya. Nunya bismuth. All right. For homework, complete 6.4